thank you as always for having us. I'm Nell, and this is my colleague Kathy, and we're from Sheffield Hallam University. And so we're talking today about the coat hanger, which is this sort of like toolkit framework that we've developed that has many, applications, but we're really focusing today on this idea of transitions. So when we think about transitions, obviously we think about, people coming and the skills that they've had, as, was so beautifully discussed in our keynote. But what we know as well is that people come in with different ideas of what it's like to be a scientist and what being a scientist means. They have different perceptions of what they want to do as a career. Many students decide not to become a scientist. Many students decide that it's not for them, it's too hard, it's too challenging. So what we wanted to do is we wanted to try and increase diversity. And by diversity within the project that we're going to talk about, we were predominantly looking at pupils with free school meals, as well as students in schools that had high levels of ethnic diversity, and looking at how we can encourage them to transition from studying science within school to studying science within higher education. So we've got this coat hanger. Everybody loves a visual. So we've got this coat hanger. So it's got these three sides, and these three sides are sort of really key to the approach that we've been taking for our widening participation outreach. And that is firstly co-design being really important, and thinking about designing what we're doing with our target audience and not being prescriptive and think about what we think they need, but actually taking the time to sort of know and get to know the sort of stakeholders involved in the project. In terms of the projects that we've been doing, we've been basing them on real research. So students, school students, the public can really feel that they are doing science and hopefully increase their science identity. And then we've also been using student researchers because I read very white, very middle class. I'm not going to go into a school and be a great role model to somebody who isn't white, middle class, or middle-aged. Whereas, our students are much closer to both age as well as lots of other demographics to the people that we're trying to encourage to take to undertake science later on in their educational journeys, as well as it is just a really amazing experience for our students, and we'll talk a little bit more about that later. So what we did is we've co-designed a soils chemistry project, and to do that, we've had a multidisciplinary team. So in terms of the co-design, we have a team of researchers. So you've got me as microbiology, we've got Kathy, who's really good at engagement and qualitative and quantitative research. We've got people from geography, and we've got chemistry and environmental chemists as well. And we co-designed this with school and college teachers, and we did this within a multi-academy trust. We worked with several different layers of their management as well as the class teachers. And the research question we had was all about the soil and the interconnectivity of soil characteristics with the microbiology, antibiotic resistance, and heavy metals as well. So it was embedded in proper science. We've been really fortunate in this project that we've had funding from NERC, from the Royal Society of Chemistry, and the Microbiology Society, which has allowed us to pay our student researchers, which has been really important, both for the project and for them, and we'll touch on that later on. So, sorry, I'm getting confused with the, okay, cool. So, as I said, we were looking at sort of the transitions from students going from studying science in secondary schools and then them choosing to do it at post-16 and then come into university. So why did we think this was important? Why was this a topic that we even started looking at? So there was three main reasons. Firstly, was that you can't be what you can't see. And this is one of the reasons we was really passionate about our students and our student researchers going into schools and being the people that undertook the outreach, because they were a much better representation of society than me and Kathy are, that are really only ticking one of the boxes of what kind of person you can be as a scientist. We wanted to increase people's science identity, so trying to get students to feel that they are a scientist, or at least could be a scientist. It was something that was possible to them. And we wanted them to know that they could do it. Like, actually, they might want to be a scientist, but have no idea how to get there. So we wanted to, through the project, make them feel that science was more accessible. It was something that they could do if they wanted to. And as I said, we did a lot of co-design work. And before we even started the project and looked at applying for grants, we did some teacher focus groups. And those were really underpinned by what the teachers were telling us. They were telling us that people weren't studying science education, they weren't studying science in higher education, because they didn't have the aspiration to do it, because they didn't know any researchers. They thought that you had to be an upper-class white man to be able to be a scientist, and that they didn't know how science worked. They didn't like getting things wrong. They didn't like not knowing the answers to questions. So we have this approach, we have this coat hanger, we have these three really key components. So because of that, we had three research questions. Now, obviously the second one, how does soil pollution impact soil bacteria? Probably not for you guys today, but if anybody really, is hankering after some like hardcore microbiology, James, we can chat about that later. Yeah, and Gemma as well, who is also a microbiologist. So the things we're going to look at today are, can higher education student-led interventions increase the visibility and accessibility of science research for school students? And then the third one, which is what impact does this then have on the student researchers? Like what impact is being involved in the project having on our student researchers?
Tag in. Thanks, Mel. So I'm going to tell you what we've done today. This is very much a project which we have completed phase one of and now have thousands of questionnaire data analysis sitting on our desk ready to analyse, but we've done a bit of preliminary analysis, so I was going to talk to you about the preliminary results and what we found. So what did we do with these student researchers? So we started off by employing a group of student researchers. So these were from our undergraduate or master's programme, and we employed 22 undergraduate student researchers in total. And being able to pay these students was really important because it increased the diversity of the applications that we've got. Some of the students for underrepresented groups have many other responsibilities, which means they quite often can't undertake unpaid work at the university, voluntary work. They might have to do work outside of university to support their families. So being able to pay them was important to be able to try. And it did work, actually. We got a much more diverse cohort of applicants than we would normally do if we asked for volunteers, as we do sometimes in our outreach work. The other thing that was important for us was that the students could get some sort of formal recognition for the work they did. So they all got the opportunity to undergo STEM ambassador training. So our local STEM hub representative undertook some training with the students. So they're now STEM ambassadors and they've got that. But also, I know we've talked about transitions through school and to higher education, but this project was also about supporting retention and students transitioning through higher education. You'll see with some of the comments we've got later how the project has helped these students almost like re-engage with science and re-fall in love with their subject, and also with potential careers as well. So in terms of their employability, their skills development, evidence for their CV, we know now, I think somebody's talking about having a degree is just not enough later on. That it isn't enough anymore. Thousands and thousands, hundreds of thousands, I don't know how many people are graduating now with a biosciences type degree, but you need to be a fully rounded graduate to get that job. So this is an important opportunity for them. So we've designed this project where you can see some of our students there that stood with buckets. So there were the kits they took out into schools with us. So they took these buckets and we went and dug up soil samples with the kids. We did some initial experiments in the school with the kids. We then took the soil away and our researchers then went into the lab and used that analytical equipment to do some more advanced analysis. And then we went back into the schools and presented the data to the kids to show them what we'd found in terms of antibiotic resistance, microbiology, etc. Heavy metals, should I say. The students were involved in all steps of the project, so from design through to the lab work, through to the ideas about how to keep the engagement with the schools as well. So they came up with some really good ideas too, stuff that we would never have thought of doing. So the schools were very keen when we co-designed this to keep the contact up whilst we went into the university and did all the analysis, and they likened it to having like a soap episode coming out every week, so it really kept their students engaged. And immediately they were like, oh, we can do a TikTok. And we're like, what? We like, what? If you want to do that. So off we go. We got a TikTok account and they were brilliant. They made little TikTok videos every week when they're in the lab. And some of these TikTok videos, they've got hundreds and hundreds of hits, just these little snippets about, even from as simple as this is what a big, a big freezer looks like for the kids. They've never seen a science lab before. Some of these kids, they would have maybe 1 pH meter, because quite a lot of them are from highly deprived areas, 1 pH meter for the whole school. or they'd never seen the stuff that we were talking, which we were talking about, the very simple equipment. So just being able to see inside science lab as well as them being able to make these videos was brilliant. And they really came out themselves. I'm really proud of what they did. And we would never have thought of doing that. So by having them working with us was great. I think we have reached about 1,800 school students to date at the moment. We might have a phase 2 this year if we can handle it. And we've got all this data to analyse. So that's in a nutshell what the project entailed. So some initial preliminary analysis shows, and we've only analysed some of the young kids at the minute, we went right through to year 12s. So right from primary school kids, little ones, right up to year 12s, through all the key stages. And the young children, we did a pre and a post questionnaire with the kids. And it ranged things like what they thought about science, a bit around their science cultural capital and their science identity. The young kids were showing indications that they were more interested in maybe being a scientist or going into some sort of STEM career, having those aspirations or at least thought about it after we visited them. There's indications that their science identity had increased, so they're actually becoming more confident in their science ability, just as an example. And that also that their cultural capital score increased as well. So actually engaging more in science after we've actually done this intervention with them. So that's only the beginning of the analysis, but just from the conversations we'd had when we're in school as well, we know that's pretty representative of what's happened as an impact. The students themselves, so these are some of the year 8 kids, I think we went into, also some quotes to some of the year 8 kids. So the staff said the sessions went down really well and really loved having our students running the session. So we would go in and our students would actually lead the session. So we'd go in to make sure everything was okay, but they would lead these sessions, which obviously was excellent for their skills development. The school teachers really impressed with them. The kids loved having people who were young role models and looked like them. We'd go out into the grassy area outside school with a group of kids and be like, right, kids, put them into groups, like, right, pick yourself a scientist. I was always chosen last in my group. They properly imprinted on these students who would be, be just like them. You've got the cool boys were there, and there's the, we went into more ethnically diverse areas as well. We had more ethnically diverse students with us too, and it really shows them. And then, they're a little bit disappointed when they were left with the academic, but there's that really good relationship going on. So everybody's really impressed, and the students are saying things that's really opened my eyes to science and being a research scientist too. Oh yeah, I forgot about that one in the middle at the bottom. This is just one of the comments that somebody said, and I think this is like, success. It was better than wagging. So if you don't know what that means, that's not in your local dialect. I have referenced the Urban Dictionary underneath, which I think is a great achievement at a science conference, which meant skiving, bunking, or skipping off. So, but for a student who's obviously not engaged at school, to say, actually, this was really good. And the teachers were saying, I've never seen the class so engaged, because they never normally would get an opportunity like this. And kids were saying things like, oh, they'll never come back to us, miss. Came back the first. They don't come back to schools like us. So for us going back again, and it really, really inspired them. And then just to finish up, because I know that we're a bit short on time, in terms of our students as well, it's having a really positive, so our student researchers really saw positive impact. So we've done a study about students getting involved in outreach in general, but particularly on this co-design project. A big thing that's come out of it is because we work with our students as partners, so rather than us sitting as academic and then, sitting students doing what we say, they're very much equal to us, and their decisions and everything, the way they want to run the project. Things have been said like this quote here, it's made me feel, working with academics has made me feel like an equal and for the first time a proper scientist. And that's been a really common theme. Their confidence and their skills have increased. The last sessions I went into, it was a really big school. They had a lecture theatre for their school assemblies of about 350. And the 2 students I took with me were terrified at the beginning, but they stood up and they did it, and they were so proud of themselves. They wanted a picture in front of the lecture theatre and everything, and their confidence has really grown. And not only has it grown in terms of science communication, but they can also recognise how it transfers to their academic studies as well. So they also recognise how it's increased their attainment, which is lovely. And like I said earlier, it's relit their passion for research or wanting to be a microbiologist, etc., different specialities. Oh, that's the one at the end popping up, so a surprise then. So that's what we've been doing in a nutshell. It's been a really impactful project, and that's what we wanted to do. All of our time is precious, so we wanted to bat smarter, not harder, is one of our favourite phrases, is to have hit as much impact as we can. So not only reach school audiences, but have a transformative student experience for our students, but also get some actual research. The science is being written up as a science publication, and we'll hopefully get some sort of pedagogy out of this as well. So thank you very much. Any questions? Very welcome.
Thank you very much, Katherine. We have time for possibly one question. And don't forget, there's the Padlet too. If you feel, please feel free to ask your questions there. One quick question. The training that you did for the undergrads, and first of all, the year levels, did you choose from across years, or did you just choose finalists? Or
No, we chose from across anybody, open from level 3,
okay.
So foundation right up to master's level. Yeah.
Okay. And did any of them think of career? I'm talking about finalists, possibly, of career choices based upon the experience. They think of going into education or teaching or that sort of thing.
Yeah, so some of them were like, oh yeah, I was thinking about being a teacher. Not anymore. But that's also really genuinely helpful, isn't it? That you're not going to go and spend 2 years writing your PD certificate. Well, then some of them were like, I didn't know that this kind of thing going into talking, they didn't know that science communication was a job. So a lot of them have expressed interest in science communication. But then actually a lot of them were like, oh, actually, I didn't think I wanted to do research, but actually maybe I do. So it really engaged them in the research as well as sort of the more perhaps what you think it would be with the communication they're working with young people.
And if we get more diverse scientists, we know we lose diversity in research as they progress through their careers. So if we can increase that diversity somehow, we're going to have better science, aren't we?
Yeah.
Better science.
Absolutely. Yeah. Thank you very much
again. Thank you very much.